Assalamualaikum. So in this numerical, you have to convert four bearings to back bearings, and the bearings are given in quadrantal form. So there are two ways to do this. One way is that you can convert these quadrantal bearings to whole circle bearings, and then just add or subtract 180 degrees to convert them into back bearings. And if you want to convert these quadrantal bearings directly, that's also very simple. You just have to understand how it's done, and then it would get very simple. So let's see this part. See, the fore bearing of the line CD is south 60 degrees 45 west. So in order to start, we need to make the grid at the point C, and the bearing, fore bearing while standing at C looking at D is south 60 degrees 45 minutes west. So that means it would be in this quadrant over here. And starting from the south, the bearing is 60:45. And in order to see what the back bearing would be, we should make the grid over here at this point D. So I'm making it over here. This is point D. And the knots would remain the same. And for this continuation of the line, this would be the bearing. Now remember, in whole circle bearing, the angle or bearing always starts from the north clockwise, while in quadrantal bearing, it either starts from the north clockwise or anti-clockwise or from the south, depending on which quadrant we are talking about. So over here, this is the bearing that is under consideration, and this was the front end, and this is the back end. Now you can see that this angle is equal to this angle or this bearing, so that means this 60:45 remains the same in both cases. The difference is in the quadrants. So if the fore bearing was south 60:45 west, now it has become northeast. So the quadrantal bearing would become north 60:45. This would remain the same, and east. So that means whenever you have to convert quadrantal bearings from fore bearings to back bearings or vice versa, the value of the bearing would always remain the same, but the quadrants would change. So the north would change into south, the west would change into east. So if you want to convert this one, south 30-30 east, this would become north 30-30 west. It's as simple as that. Now, again, this is similar, back bearings to forward bearing, just the reverse process. Let's see the summary. So in this one, what we need to do is that the magnetic bearing of a line is given, and they are asking you to find out the true bearing if the declination is this much. So they have given you the magnetic bearing, and they've asked you to find out the true bearing, and they've also given you the declination, and they have shown you the direction of the declination. It could be east or west, like we discussed. So in this case, it is west. So if we draw a picture of this, first let's draw the grid, and the bearing of the line is 135:30. So that means the whole circle bearing would be somewhere over here. This is point A and this is point B, and the bearing is given, which is 135:30. Now this bearing is magnetic bearing. So that means it is from magnetic north and not from the true north. And what they're asking you to do is find out the true bearing from the true north. And the declination is 5 degrees 15 minutes west. So like we discussed that the declination could be declination east or declination west. In this case, it is declination west, which basically means that the magnetic north is towards the west of the true north. So this would be the true north, and to the west of it is magnetic north, and this angle is 5 degrees 15 minutes. Now, since the magnetic bearing is given 135:30, which was from the magnetic north, what we have to do is from the true north, we have to find out the bearing of the same line. Now, since we know the difference between the two and we know the bearing from the magnetic north, the bearing from the true north of the line AB would be 135:30 minus 5 degrees 15 minutes. Since it was the bearing given was from the magnetic north, and the magnetic north was towards the west. Had it been towards the east, then we would have added the declination in the magnetic bearing to get the true bearing. So this is how you do it, and similarly you can do the part B, which is basically almost similar. Let's see the last numerical in this slide. So in this numerical, what you have to do is you have to find out the interior angles B, C, and D. Let me put it on the sketchboard. Okay. So they have given you the four bearings of the lines AB, BC, CD, and DE, and they're asking you to find out the interior angles BC and D using those four bearings that they have given you. Now we can find out the back bearings as well, since we know that the difference between the four bearing is back bearing is 180 degrees. So let's try to find out the interior angle B. So the information that they have given us is that the four bearing of the line AB is 4530. That basically means this bearing over here is from A. Four bearing is 45 degrees 30 minutes. And the four bearing of the line BC that they have given us is 120 degrees 15 minutes. So this bearing is 120 degrees 15 minutes. And what they're asking us to find out is this interior angle B. This is unknown. So if you try to look at it, uh, we need to find out the back bearing of the line AB, which would be from the north. This would be the back bearing of the line AB clockwise. Now we have three different angles: the fore bearing of AB, this one, the back bearing of AB, this one, and the fore bearing of the line BC, which is this one. Using these, just by geometry, we need to find out the interior angle B. So now, as you can see that we have this bigger angle, the back bearing of the line AB, which we can calculate by subtracting, or now in this case that would be by adding, because if you draw the continuation, this is the angle 4530, the fore bearing of the line AB, and we need to find out this angle. So this would be 4530 plus 180. So in order to find out the interior angle B, that would be uh, 180 degrees plus the fore bearing 4530, and from this we need to subtract this smaller angle fore bearing of the line BC, which is 120 degrees and 15 minutes. So if you subtract that, you get the interior angle B as 105 degrees and 15 minutes. So just by using geometry, we can find it out. So that was the interior angle B. Now let's try to do interior angle D. Let's do one more. Yeah, let's do interior angle D. Now for that, what they have given us is that they have given us the fore bearing of the line CD, which is this one, 230, and they have given us the fore bearing of the line DE, which is this one, 280, 45. Now, in order to find out the interior angle D, which is this one, now by geometry, I can see that if I can somehow subtract this angle from the complete 360, I'll get the interior angle D. Now, in order to get that angle, what I already have is the fore bearing of the line DE, which is 280 45. From 280 45, I need to subtract this smaller angle, which is basically the back bearing of the line CD. Now the fore bearing of the line CD was given, which was 230, From that, I need to calculate this back bearing of the line CD. So if I can project that from this whole angle, if I subtract 180 degrees, I will get this angle, which is basically the back bearing of the line CD. So if I subtract 180 degrees from 200 degrees in 30 minutes, I get 20 degrees 30 minutes. And if I subtract that from the fore bearing of the line DE, I get the interior angle D, which would be 99 degrees 45 minutes. So just by using the fore bearings and the back bearings, and then by using geometry, we can find out the interior angles. And this is true for every closed traverse. As long as you have fore bearing and back bearings, we can either find out the interior angles, or we can plot interior angles in the field. If we are laying out a building, let's say, and you want to plot those interior angles in the field, uh, since the compass doesn't directly give you the interior angles, you have to work with bearings. So by using the fore bearings and back bearings, by using prior calculations, you can go in the field and execute those interior angles if you know what should be the values of fore bearings and back bearings. So that was the numericals for this slide, and we'll meet in the next lecture and continue the discussion to some more numericals.